Hi, welcome to AulaUE. My name is Maria, and today we are going to see an example on how to use Gauss-Jordan method to find the inverse of a matrix. Let's suppose that we are given the following example. A is equal to 0, 1, 2, 1, 0, 3, 4, minus 3, 8, so this given matrix, and we are going to apply Gauss-Jordan method in order to find the inverse. So we write down A and then the identity matrix, apply Gauss-Jordan, and find out the identity on the left and the inverse on the right. So the first thing that we have to do is just copy matrix A, 0, 1, 2, 1, 0, 3, 4, minus 3, 8. And on the right hand side, we just copy the identity matrix. This time is the identity of order 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now we just need to do operations using Gauss method in order to make zeros below the main diagonal. So we have to switch the order of row 1 and row 2 because we cannot operate directly with the first row as it is. So we just copy the first row, in this case the previous second row, and we copy in the second row the first previous row, and of course we just copy the third row as it is. Okay, now we can apply Gauss by doing operations using the first position as our pivot row. So 1 it's going to be our pivot row, and we want to make zeros below. We are quite lucky because this time we already have a 0 in the second row, so we just need to operate in order to cancel minus 4. So if we operate a little bit, we just have to substitute the third row by itself minus 4 times the first row. And if we do that, we just get the following numbers. We copy the first row as it is, 1, 0, 3, 0, 1, 0. The second row also remains the same, so 0, 1, 2, 1, 0, 0. And we just need to operate the third row with the first one. So 4 minus 4 is 0, minus 3, minus 0 is minus 3, 8 minus 12 is just negative 4, and then 0 minus 0 is 0, 0 minus 4 is just minus 4, and 1 minus 0 is just 1. Okay, we have to go on applying Gauss, and this time we select the second row as a pivot row because we want to make zeros below without undoing the previous zeros. We don't want to remove the previous zeros. Be careful with that. So we just operate. This time we have to substitute the third row by itself plus 3 times the second row in order to make a 0. So we just copy the first 2 rows as they are, so 1, 0, 3, 0, 1, 0, 0, 1, 2, 1, 0, 0, and we just operate with the third row. So we have to do the operation, and we get 0, 0, minus 4 plus 6 is 2, then 0 plus 3 is 3, and then we get minus 4 and 1 for the last positions. They remain the same. So we already have 3 zeros below the main diagonal, and now we have to make zeros up in the upper part. To do so, we just have to select once again the pivot row. This time it's going to be the last row because we don't want to remove the previous zeros. And we have to make zeros in the positions up, this time in number 3 and number 2. Okay, to do so, we just operate a little bit. This time, remember that the pivot row is the third row, so we substitute the first row by 2 times the first row minus 3 times the third row in order to cancel. And the second row, we substitute it by itself minus the third row because we just want to cancel the second position. Okay, if we operate a little bit, we get 2, 0, 0, and then we get minus 9, 14, and minus 3. Okay, 0, 1, 0, minus 2, 4, and minus 1 in the second row. And of course, the third row remains the same, so 0, 0, 2, 3, minus 4, and 1. And this time we are quite lucky because we already get 3 zeros in the upper part. So we have zeros below the main diagonal, zeros up main diagonal. So we just need to make ones in the main diagonal. So we need to have these three positions as being a number 1. So we just need to operate a little bit with the first and the third row because the second one it's already a 1 by dividing each row by 2 in order to have a 1 in that position. So we substitute row 1 by 1/2 of row 1 and row 3 by 1/2 of row 3. If we do so, we get 1, 0, 0, 0, 1, 0, 0, 0, 1 as expected on the left-hand side, the identity matrix. And on the right-hand side, we have minus 9 divided by 2, 7, minus 3 divided by 2. The second row remains the same, minus 2, 4, minus 1. And in the last row, we just need to divide by 2, so 3/2 minus 2 and 1/2. And we already find out the inverse matrix of our given matrix A. This right-hand side is just inverse matrix of A. Okay, and that's it. I hope you enjoyed this video and see you soon.